Hello class, welcome to Earth Science Outside. I wanted to go over some stuff with the igneous rocks that you were reading about or looking at on the videos. So I have some rocks outside here to show you and go over some of their characteristics. The biggest thing we want to talk about today is intrusive versus extrusive and lava versus magma. So lava, remember, is on the surface. It's going to cool on the surface, which gives you the extrusive rocks. Magma cools below the surface, and it's going to give you the intrusive rocks. So let's look at a couple rocks here, and let's talk about what we see with these rocks. So first here, I've got a piece of granite. Okay, so this is the granite. Now, why this is called intrusive? Because you can see the crystals in it. It's speckly. You can see all the dark crystals in there, the white crystals in there. Those crystals are very visible to see to the naked eye. So that's going to be an intrusive igneous rock, and this is known as granite. Okay, so that's one piece of granite. I have another piece of granite here, which is similar in some respects. So here's another piece of granite. Of course, you see the color's a little bit different. The feldspar in here is more of a pinkish color versus the white feldspar in the other one. This one, the crystals are larger. I'll bring back the other one here. Okay, so you can see the crystals in this one. The black is much larger than the black ones, the crystals in here. This is also intrusive, but this one cooled even slowly, and as it cools slower, the crystals have time to grow. Okay, so igneous, intrusive, both granites. Okay. Now I have another igneous intrusive rock, which is known as a granite pegmatite. Now this one, the crystals are much larger, and so which means it cooled even slower. So here's another example. So this is granite pegmatite. Okay, these are actually quartz, smoky quartz in here, and the feldspar is the white. Okay, these crystals, you can see they're huge, very large compared to, let's say, this one that I showed you a minute ago, or a second ago, and then this one here. Okay, so these are two granites and a granite pegmatite, okay, known as a pegmatite. So those are igneous, intrusive rocks. Now let's talk about extrusive. Extrusive means they form from lava, which is on the surface. So they cooled fast, very, very quickly, within seconds. And as they're cooling, there's gases in them that want to escape. And as they do that, it might leave behind some holes in the rock. So let's pull out an igneous rock that's got holes in it. This is called a vesicular texture. All right, so this is vesicular texture. You can see the holes in this rock very easily, very large holes there. The gas is escaping very, very quickly. Okay, this is known as vesicular basalt. Okay, so that's vesicular basalt. Here's another rock. Also, you can see the holes in it. Vesicles, which is vesicular, reddish in color, which means it has lots of iron in it. And this is called scoria. Okay, scoria. Another vesicular basalt that I have here is this one. Okay, the holes are much larger compared to the other one I had. Also vesicular basalt. And then another vesicular rock that I have is known as pumice. Now pumice is pretty unique because pumice actually floats in water. This will actually float in water. The density is below or less than 1. Vesicular, you can see the holes in that rock cooled very, very fast. Okay, so vesicular. Also, if you look at this rock, I'll bring this rock back. We also call this fine-grained because you can see you can't really see the crystals in this. It's all pretty much the same color. This is called fine-grained. This vesicular basalt would be also called fine-grained because you can't see those crystals in there. They're minuscule, microscopic. So they cooled very, very fast. No time for those crystals to grow, so they're called fine-grained. And then I have one more extrusive igneous rock, which has a glassy texture, and this is known as obsidian. So here's some obsidian. Okay, so this is obsidian. You can see the shine on that. It's actually glass, and light would shine through it if it, I don't know if you can see light pass through there or not, probably not. But some of the obsidians you actually can see through because they are volcanic glass. Okay, so that's extrusive, cooled very, very fast, has that glassy texture. Right. I have a few questions associated with this video. Hope everybody's doing well. Get outside today. It's beautiful out, beautiful blue sky. And tonight there's a meteor shower looking in the southeast part of the sky. I'm not sure how many meters per hour. I think around 30 or so. But if you can check that out tonight, that'd be awesome. And talk to you guys soon.